So far we've talked about parabolas that are vertical and they open up or down. In this video, we're going to start exploring horizontal parabolas and describe how they're created, as well as identify their focus and directrix. Horizontal parabolas result when we have an x alone and a y squared in the problem. So notice here that we have x alone and y squared, x alone and y squared, x alone, and then y within something that is squared. So whenever we have y alone with an x squared, those parabolas open up and down, and whenever we have x alone with a y squared, those open left and right. Now a couple of things you want to note. First, notice that when the value out in front here is positive, so here we have a positive 1 out in front of that y squared. When it's positive, we open up to the right. And this should make sense to you because when we had y equals x squared, it opened up, which was towards the positive y values. And here, to the right, is towards the positive x value. So when we have x equals y squared, that's going to open up to the right. Now, if we have a negative out in front, you're going to notice that it opens up towards the negative x value. So here we have it opening to the left. So notice those slight differences there. Then the other thing we need to note is that we can actually find this vertex point here. Notice that this is very similar to vertex form for a vertical parabola. So we would have y equals x minus h quantity squared plus k for a parabola that opened up and down. So notice here that to find our vertex, we have h outside and k on the inside, and that's because of the switch that this is a horizontal parabola. So noting that small difference, our vertex is going to come from our equation written in vertex form, but the k value is now the opposite of what's inside, and the h value is on the outside. Now the nice thing about horizontal and vertical parabolas is that the directrix and the focus pretty much work the same way. The only difference here is that when we have a horizontal parabola, our directrix is now going to be a vertical line, so it'll be x equals some number, and our focus is going to be to the right or to the left of our vertex. So what we're going to do for each of these examples is we're going to look at the information provided and we're going to find the missing focus or directrix. So here what I can see is my vertex occurs at the point x is -3, y is 2, and I can see that my directrix is at x equals -5. So what I notice here is that my directrix and my vertex are 2 units apart. And remember that our directrix and our focus are the same distance away from every point on that parabola, the vertex included. So if our directrix is 2 units away from our vertex, our focus is 2 units the opposite direction, in this case to the right, of our vertex. So here we can see that our focus is occurring at -1, 2. So we have a focus point here that was missing of -1, 2. And again, note that this falls right on your axis of symmetry. So these work in the exact same way, it's just now we're flipped on our sides. Then here, if we look at this next one, we can see that we have a vertex point here at x is 4, y is -1. And we can see that our focus is 1 unit away here to the left. Now what this means is that our directrix is going to be 1 unit away to the right, so that's going to be right here. It's going to be a vertical line at x equals 5. So that is my directrix line. So again, these work in exactly the same way as they did with vertical parabolas. We're just moving it to the right and left instead of up and down.